So let's discuss this variation. What is variation? In variation, we see how one variable varies with respect to other variable. Okay. So let's take an example, real life example. Maybe this pen cost 2,000 rupees. So one pen costing 2,000. So two pen,
4,000.
Three pen, 6,000.
6,000.
You see, I'm increasing the number of pens and the total cost is also increasing. I'm decreasing the number of pen, total cost also decreasing. So the idea here is these two variables. What are the variables I'm choosing here? One is the number of pens, other is total cost. They have some relation. One increasing, other also increasing, one decreasing, other also decreasing. If we have the relation like this, such variation is called direct variation. So what is the direct variation? If one variable increases, other also increases. If one variable decreases, other also decreases. So such relation is called direct variation. How we write? Let us say these two variables are x and y. So x is directly proportional to y. Okay, this also can be written as x1 by x2 is equals to y1 by y2. This is the relation for direct variation. What is 1, 1 first case? What is 2, 2 second case? So Frederick, can you give me some other real life example where you find direct variation? Can you give me some real life example where you find direct variation? Give. Real life example. Give where you have direct variation.
Okay. Well, you told about the price and the cost. Sorry, the price and the amount, the quantity. Maybe let me think.
Let me give one more example, then you give. If you do more practice for the GMAT problem, your final score will be more. If you do lots of, if you do, much more practice, solve so many problems, your score will be very, very, very good. And if you don't do practice, only class problem, after that you don't open the book, score will be less. So more practice, okay. So the number of questions you do the practice and your score, final GMAT score, that is directly proportional. Okay, now you give other example.
If you eat a lot of food, then your weight will be very high. Maybe you will be very fat.
Okay, if you eat heavy food or more food, weight be more. Yeah, it's simple. You buy more mango, you need to pay more money. Or in other way, you can see, let us say you are driving your car. You drive your car for longer time, you'll be covering more distance, right? You drive your car for 1 hour, you cover some distance. You drive your car for 10 hours, definitely you'll be covering more distance, provided speed is constant. You know, okay. I hope this direct variation is very clear. Now let's go to the next one. Next one is the inverse or indirect variation. Now this is interesting one. Inverse or indirect variation. What's happening here? These are two variables. You see here, these two variables. If you decrease one, other will increase. Or if you increase other one, other will decrease, or you decrease other one, other will increase. So they have the different impact, like one increases, other decreases, or one decreases, other increases. That is called inverse variation. Is inverse variation clear to you? If one variable increases, other decreases, right? Let us say there are two variables, x, y. When you increase this one, this will decrease. or when you decrease this one, this will increase. This is called inverse variation. So here we can say x is inversely proportional to y. This can be written as x1 by x2 is equals to y2 by y1. Do you notice the difference? Previous case x1 by x2, y1 by y2. Here y2 by y1. Because this is the case of inverse variation. Let me take the real life example. You go to your office, you drive your car faster, you reach office early, right? It takes less time. When you drive your car very slow, so time taken to reach to office be more. So can we say time and speed are inversely proportional? Indirect variation?
No.
Because no, it is yes. Why no? If the speed is less, time taken be more.
Yes, yes. I heard that you were telling that it was direct variation, but no, I understand.
Inversely proportional. Okay. Right. If I drive faster, I'll reach early. Okay. We can say the speed and time are inversely proportional. So we can say S1 by S2 is equals to T2 by T1. I will take one more real life example for the inversely proportional. Let us say this bottle is filled with water. Okay. Let me drink some part of the water. I'm taking two variables. One is the amount of water I drank. Other is the amount of water left in the bottle. If I drink more water, the water left in the bottle will be less. If I drink less water, water left in the bottle will be more, isn't it? Are you getting my point, what I'm saying? If I drink more water, so water left to be here is less. If I drink less water, water left here be more. So this is inversely proportional. Now I'm giving a scope to Frederick to create one more real life example for inverse variation. Can you?
Maybe the law between offer and demand. If you have like a very high price, then the demand of that will be less.
Yes, so you are saying demand and cost, right?
Yes, cost.
Yes, when you increase the price suddenly for something high, so demand will less. Okay, so that is accepted. Did you copy this one?
Yes, yes.
Okay. Now let's go to the next one. Joint variation. What is this joint variation? In case of joint variation, the simple word I can say, you will be having more than two variables. You'll be having more than two variables, or you can say it's a combination of direct and inverse. So here I took three variables. X is directly proportional to y into z. So this is the joint. If you want to split this one, you can split. The meaning of this one is x is directly proportional to y and x is also directly proportional to z. And if you club this one, so this is going to be x is directly proportional to yz. Or this also can be written as x1 by x2 is equals to y1 z1 by y2 z2. Now I'm taking one more example. You try to club this. Let us say is given x is directly proportional to y, x is directly proportional to z, and x is inversely proportional to w. Can you club all these three? After clubbing, what will get?
Yes, x1 under x2.
X is directly proportional to, first you club all.
Okay. Y, Z, and W.
Yes. And after the next one by x2 is equal to, we can do that one. So I was just testing, how to club. So you know how to club this.
Okay.
So let's close this.
Yes.
Next one is the partial variation. Generally in the GMAT, they test here. Sometimes it's not frequent. Partial variation. Partial means what? Some part of the equation doesn't change. So you can see here x is a variable, y is variable, and this is constant. So the value of x is totally depend on the value of y. It does not depend on the value of c. Why? Because c is a constant term, right? C is a constant, is not going to change.
Yes.
It's like, basically this can be used for the business terminology. Let us say when you set up any business, right? And I set up a business to produce the water bottle. Okay. So whether I produce one water bottle or I produce 1 million water bottle, I need to have the infrastructure. I need to have the electricity. I need to have the manufacturing plant. So these are the fixed cost, that is C, constant. And after that, if I manufacture or produce one bottle, so maybe I need this much iron only. If I need more bottle, so I need more iron sheet, more effort. So right. So in the business terminology, this type of equation can be used where you can see initial cost is something which not going to change whether you produce one bottle or 1 million bottle. But variable be there. Other variable like you are producing more bottles, so you need to spend more iron sheet. You need to hire more labor. You something like so. But there are some. So this is called partial variation, where some part is varying and some part is not varying. So this can be used here. I hope it's clear.
Yes.
Okay. So let's close this.
Yes.
So I'm done with this, what to call